All right, hello guys, how are you? We are starting with our Unit 2B review, and we're starting with, this is not Activity 5, this should be Activity 9. Okay, so we're going to start with Activity 9, and Activity 9 is all about slope. Okay, so slope is measuring how inclined or declined a line is. Basically, it's asking how steep is this line. So we're measuring how steep this line is. So this would be a steeper line and would have a greater slope than something like this. So this has a steeper slope, it's a steeper line, it has a greater slope, and so since this one is not as inclined, it should be a lesser slope. And then if we do something like this, even though it looks like it could be steep, it's kind of in the middle, it's got a negative slope because as we read from left to right, it decreases. So it would have a negative slope. Alrighty, and just a couple of reminders, we usually use M to represent slope. Don't know why they picked M, but that's what they did. We have our formula for slope. It's a ratio. It is the ratio between the change in y over the change in x. And then here we have a couple of different, ask which ratio does not represent the slope of a line. And the slope of a line is your change in y over your change in x. We call our change in y our rise, so we could say rise over run, so that one is fine. Our change in y over our change in x is fine. And we measure our vertical change, so how much we change going up over how much we change going horizontally, so this is fine. That's our y value, that's our x value. So the only one that's not okay is this one. This is our run over our y's, or run over our rise, or our x over our y, or our horizontal over our vertical. So this is inverted. So if we, the reciprocal is fine. This is not though. Okay, so now that we've kind of reviewed some vocabulary, let's move straight on into our guided practice. So first things first, ask what is the slope of this line? So when we have a graph, the best thing to do is find 2 points where it's on 2 crosshair points, and then count how far up does it move. So 1, 2, 3 units, and then how much across it moves, and it moves over to the right 1 unit. So my slope is 3 over 1, which is just 3. Now if I look at my equation, you can see that that number right here, this 3, that's our slope. What the coefficient of x is our slope. That is our m value. Okay. And then now let's move on to number 2. So number 2, we have a line that has a slope of 2. Give the coordinates of 2 points that could be on this line, and then show that your 2 points lie on a line that has a slope of 2. So this one, it doesn't give us anything other than that our line has a slope of 2. And so what we can do is we can pick any random coordinate. So, boom, we'll go over here. Here we go. So let's pick this point. That would be the point 3, -1. Okay, if I want another coordinate that has a slope of 2, I can rise up 2 and go over 1. So that would be me moving at a ratio of 2 over 1. That's our slope. And when I do that, if I do that a couple of times, I've got some more coordinates. I can also go down 2 and left 1, since that will extend my line in the opposite direction. So here's my line that has a slope of 2. And let's see, so we picked this coordinate, so let's just pick another coordinate that's on this line. Let's go with this one for fun, and this would be 1, 2, 3, 4, 5, up 1, 2, 3. So 5, 3 would also be on that line. And again, you could pick any random coordinate and then just move at a slope of 2. Our vertical change would be 2, our horizontal change would be 1, so we'd be going up 2 and to the right 1 unit. Alright, 3. Determine the slope of the line, graph to the right, and remember the slope formula. So we can use the formula. We could pull 2 coordinates off this graph and then use our slope formula, or we can count like we did on number 1. So this one was kind of tricky because it's really, really hard to see where the crosshairs are. Like at first I thought it was up 1 and over 2. But if I do that continuously, it doesn't really get to, it starts kind of deviating. So I found that the easiest thing was to find the y-intercept and the x-intercept, and then I could count up 3 and write 7. So my slope is 3 over 7 because this is my vertical change. I went up 3. My horizontal change is right 7, so 3/7. Which is close to half, which is why 1 over 2 looked like it was right, but you could tell it's just a little bit too off. So that one was a little tricky. You could also use your slope formula. You could get the coordinates of this point, which is 0, -3. You could get the coordinates of this point, which is 7, 0. And then you could plug them into your slope formula, subtract, boom. Alright, so let's move on to the next slide. Or not next slide, next page. Okay. Alright, so number 4. And we're going to use the slope formula here. So we have 2 points, and we want to know the slope in between them. So remember, our slope formula is m equals y2 minus y1 over x2 minus x1. And which coordinate, like the y, you could also do y1 minus y2 and x1 minus x2. It really does not matter which coordinate is x and which coordinate is y. I'm sorry, which coordinate is 1 and which coordinate is 2. It just matters that you subtract in the same order. So, like these 2 points should be from the same coordinate, and these 2 points should be from the same coordinate. Or these 2 coordinates should be from the same point. Let me say that correctly. Okay, so, let's see. Let's start with our y's. So, honestly, I always start with y and I always look at what the bigger y is. So, 9 is larger than 6, so we're going to do 9 minus 6 on top. Now, I used 9 first, which means I have to use the 4 first on the x's. So, I'm going to do 4 minus 8 on bottom. Okay, so let's subtract. So, we have 9 minus 6, which is 3, and 4 minus 8, which is -4. So, my slope is -3/4. It does not matter if the negative is on top, on bottom, or out front. The point is that the whole fraction is negative. It doesn't matter if it's 3 over -4 or -3 over 4, because the end result is -3/4 or -0.75, because as a decimal it doesn't matter. It's in front of the whole decimal. So when it comes to negative fractions, it does not matter where the negative symbol is. What does matter is if you have a negative on top or in the numerator and a negative in the denominator, those 2 negatives would cancel each other out and become positive. Okay, so let's move on to 5. We're going to use the slope formula again. So let's start with our y's first. Let's do 9 minus -3. Over -10 minus -5. So remember, we started with the right coordinate and ended with the left coordinate. That is completely wrong. Let me apologize because I used an X and a Y. Let's skip that. Look, your math teachers make mistakes too, and that's okay. Okay. So we're going to do, yeah, that's way wrong. we're going to do 9 minus negative 5. And negative 10 minus negative 3. So we've got I'm so sorry. It is, let me just go ahead and say this. It's 9 o'clock at night and I've just wrestled my 2-year-old in the bath. So I'm having a day. Let me change colors and we're just going to ignore that. I promise you, I know what I'm doing, I think. Okay. So let's do our y's first. So negative 10 minus negative 3. So y and y. Okay, we started with negative 10, so we're going to have to start with 9. So 9 minus negative 5. Okay, now we have that in correct order with the correct things matching up. Again, I'm so super sorry about that. I don't know. Miss Gallant's having a night. Okay, so negative 10 minus negative 3. So this minus negative becomes a positive. So this is negative 10 plus 3. Same here. Minus, when you subtract the negative, it's like adding a positive. So we're going to do 9 plus 5. Okay. So negative 10 plus 3 is negative 7. 9 plus 5 is 14. And this will reduce to negative 1/2. I can divide both of these by 7. So my slope is m equals negative 1/2. Okay, and again, I apologize for the 2 screw-ups in a row. That's unacceptable. But your teachers make mistakes too. We're human too, and we're all suffering through the quarantine isolation. We're having brain farts too. I'll be honest. I need to get back into school and back into routine just so my brain works correctly. Okay, so 6. Explain how to find the slope of a line from a graph. So we can do this one of 2 ways. Just a second. Okay, so we can do this one of 2 ways. You can either count the squares between 2 coordinates, basically how many units up or down divided by number of units right. I always go from left to right. So when it's negative, you'll go down from left to right. When it's positive, you'll go up from left to right. So I count how many units up or down and divide that by the number of units going to the right. Your other option is to select 2 coordinates and use the slope formula. All right, number 7, explain how to find the slope of a line given 2 points on that line. So we're going to, so when we just have 2 coordinates, we use the slope formula. And we're going to explain how to use that slope formula. So what we do is we calculate the change in y by subtracting y coordinates we calculate the change in x by subtracting x coordinates and then we divide the two. Well, actually, let's just say we divide the change in y by the change in x. By the way, that little triangle is the Greek letter delta and means change. So, learn something new every day. You learned a little Greek today. Okay. Alright, so, something else we call this the rate of change, because we are calculating how one variable changes in relation to the other. So how the y variable changes in relation to the x variable. Okay, so number 8, does this table represent data that has a constant rate of change? Justify your answer. So I will tell you what 99% of my students do. They just calculate the change in y. So to get from negative 13 to negative 1, we would have to add 12. To get from negative 1 to 19, we would have to add 20. And to get from 19 to 23, we'd have to add 4. And then my students would say, it's not constant, Miss Gallant, this changes by a different number. But remember, we want to calculate change in y over change in x. So we have to see what this is changing by as well. So to get from negative 3 to 0, we add 3. From 0 to 5, we add 5. From 5 to 6, we add 1. So let's see if the change of y is the over change in x is the same for each of these. So we have 12 over 3, which is 4. 20 over 5, which is 4. And 4 over 1, which is 4. So my rate of change is actually constant through this whole thing. It's equal. My rate of change is 4. So yes, it has a constant rate of change, and it's 4. So when it says justify your answer, I would say that our work here does justify our answer. We could say that we calculated the rate of change and found it to be 4 between each data point, or 4 over 1 in each data point. I think our work shows it though. Okay, number 9, Carlos buys a phone that costs $250. He pays a monthly rate of $75. So write a function x that f of x for the total amount that Carlos pays you for using the phone for x months. So we're going to have f of x equals, so let's think about this. Up front, he pays $250 for the phone. Fine, that's nice, good. Okay, each month he adds $75 to it. Now that 75 we're going to add over and over and over again. So remember, we can do 75 plus 75 plus 75 plus 75, or we can use x to represent the number of months. So however many months we have, we multiply that by 75 and add it to our 250, and then that's our function. B, make a table of ordered pairs and graph your function. So I'm going to make a quick little table. We're going to do x and f of x. Let me pull up my handy dandy calculator. Okay. So, and we'll just pick 0, 1, 2, 3, and 4, and 5. Why not? We'll just go all the way to 5. Okay, so if I don't use the phone at all for 0 months, I still paid the $250 for the phone. Okay, after 1 month, I'm going to add 75. After 2 months, and we could take this and plug this in, but remember, we're adding 75 each time. So that would be 400, 475, 550, and 625. Okay, and then it also wants us to graph it. So So please excuse my poorly drawn graph. Okay, that should be a little more even, but let's see. Okay. Let's see. I don't have a ruler. Oh, I got some sticky notes. That'll work. Okay, so at 0 months, we spent $250. At 2 months, we spent $400. That'll be fine. You know what? That's fine. I didn't get a really... if I had some graph paper, it would have done a little bit better, but it's good enough. Good enough. Okay, and then it also says remember to label your axes. So we would use months and total cost in dollars. All right, C, what is the rate of change? That would be my $75 that I increase by each month. And we might just want to say 75. We might not need the dollar sign here but I'm going to put it. I'm going to give you both. Okay, D, describe the relationships between the rate of change, the real world situation, the equation of the function, and the graph. Okay, so the rate of change, I'm going to do ROC, is $75. It's the slope of the graph. It is the, for real world situation, that's the monthly rate. Remember, oh look, the word rate, and it's the rate of change. It's the monthly rate for the phone. And it's the coefficient of x. Okay. Now I think that's all I need to answer on D. Wish I had a little more room, but I don't. Okay, so I think that should be it for activity 9, which is all about slope. If you have any questions, feel free to email. Y'all stay healthy out there, wash your hands, social distance, and y'all have a great day. I'll talk to you soon.